Hello, my name is Kevin Moffett. I'm an assistant professor at the Rutgers Business School, and I teach accounting information systems. I also teach a class called Accounting in the Digital Era for Macy students. I do teach some text analytics in that class, and this presentation will be different from what I go over in that class. But the topic is the same, text analytics and accounting. So what is text analytics? I think simply put, it is the computer-aided extraction of information from text. Since computers are now much more powerful than they were in the past, and storage is very cheap, anyone who can get a hold of a corpus of text documents and who has the right program or knows a little programming will have the ability to process large data sets and perform complex algorithms. There are many areas in text analytics. I think the most basic example is information retrieval in the Google search. Google has proprietary, complex algorithms that make them the best search engine in the world. The best at retrieving the information relevant to the search terms that you input. That's not the only part of text analytics, obviously. I don't know why this keeps popping up. There we go. There are also other areas of text analytics, including document classification. That is to say, maybe you want to determine whether an annual report is fraudulent or non-fraudulent. What about information extraction? Maybe you want to scan a document and pull out certain information such as email addresses, phone numbers, proper nouns. At any rate, all of these areas of text analytics have been pioneered and grown in the areas of artificial intelligence, computer science, machine learning. And now, as accountants, we have the opportunity of using the tools developed in other areas in the accounting context. And researchers have really taken hold of this idea and run with it. So there's a lot of accounting research that incorporates some form of text analytics nowadays. It's not uncommon at all. But I'm not so sure it's taken root in accounting practice yet. Well, let's look at a business application of text analytics in email analysis. Suppose you want to determine the tone, how positive or negative, optimistic, pessimistic, the tone of emails within an organization. Suppose you want to do that. Let's say there's some event, such as the hiring of a new CEO, or the financial crisis, and you want to see how that has affected company morale. Okay? Suppose you just want to look at one individual or a group of individuals, such as the emails from the C-suite. Now, how would you go about doing this? Well, one popular way, and probably the best way, is to use predefined word lists called dictionaries. Okay? So I'll show you a word list that Harvard developed. They developed this set of lists they call it collectively General Inquirer. So let me open up a spreadsheet with their word lists. Zoom in a bit. Okay, so here on the left are the words, and across the top, beginning with column C, are the names of the word lists. Positive, negative, hostile, strong words, power words. So there are about 12,000 rows in this spreadsheet. So let's sort by column C so we can see the positive words at the top. Custom sort. Data has headers. Positive. Right. Okay. So these are positive words. Abide, ability, able, abound, absolve, absorbent. Yes, absorbent. Okay. Accept, accomplish. Now, a lot of these words belong in other dictionaries as well. So the word ability is also in the Strong Dictionary, or accept is also in the submit. You know, you're very submissive if you are accepting, or you submit yourself. So there are many positive words. Let's see. About 1,900 words in the positive word list. So what you can do is you can count the number of times these words appear in a document and say, all right, here's the total positive score or positivity score for this document. It could be an email. All right. You could also look at negative words. Okay, so I just looked and here are a few negative words. And maybe you subtract the negative score from the positive score. And if it's a net positive number, then you say, you know, this is a positive email instead of a negative email. So this is a crude method, but widely used to detect the tone in documents. Okay, well, let's say instead of emails, let's say we want to analyze the tone in the 10K annual report. So we would take a word list, like the ones we just looked at, and then count how many times the positive or negative words appear in this annual report. There's a bit of a problem here. See, these word lists were developed, the ones that I just showed you, by psychologists, linguists, sociologists. And they are of a general application to everyday conversation, books, newspaper articles. They're not specific to a domain like business reporting. And so we may have issues in identifying positive and negative words using these dictionaries. So if that's true, maybe we should look at developing better dictionaries to capture the tone in financial documents. So in the list that I just showed you, the Harvard General Inquirer, these are negative words: cost, vice, cancer, liability, and foreign. Now, would these be considered negative words in the context of an annual report? Well, if you look at cost, which business doesn't incur costs? I think it's a very neutral word. The word vice doesn't have the same meaning in an annual report. In fact, it's used most often when you're talking about the positions of the executive, the vice president. Cancer could be a very negative word but in the context of an annual report, it's actually related to the industry the company works in. Liability, okay? Every company has liabilities. Neutral word. Foreign. It's not a negative word in an annual report. Okay, so here are some negative words that are not in the word list we just looked at. Okay, so felony, litigation, restated, misstatement, unanticipated. Okay, these are negative words that, had we used this other word list, we would not have counted them in the annual report. Now, some of you are probably wondering, well, are those words always negative? What if they're negated? So if you take the word felony, and maybe the wording is, there was no felony this year like there was last year. Well, then the word felony is not necessarily negative, right? I mean, it's positive. There was no felony. The idea is that, on average, when these words are used, they're going to be related to negative events, negative attitudes, more often than not. So when you combine the counts for all the negative words, you get a negative score that's hopefully pretty accurate. So two researchers, Tim Lofgren and Bill McDonald of Notre Dame, they created a dictionary, several dictionaries, to measure the tone in business reporting. They also have a dictionary for measuring uncertainty, litigation, strong modal and weak modal words. So how do they create these dictionaries? Well, first they extracted all the words from the 10Ks between the years 1994 and 2008. And they only looked at those words that occurred in at least 5% of the documents. So by only looking at 5% of the documents, words that occurred in 5% of the documents, they could ignore maybe names of people, names of companies, proper nouns, locations, things like that weren't really relevant. So it cut down the word list quite a bit. So they found over 2,000 negative words, such as restated, termination, and you can see that they actually were very successful in creating word lists that related to financial reporting and were limited to that, but very useful for researchers and those who who want to do text mining in accounting context and financial context. So what they wanted to see is, using this negative word list, if it would correlate with negative stock returns. Okay, so if you have more negative words in a 10K, are the results worse? So the dotted line in this chart tracks the negative word usage according to the Harvard dictionaries. Okay. So on the left side of the dotted line, that's low negative word usage. And on the very right side is high negative word usage. There's no clear pattern relating negative word usage and negative excess returns. There's no clear pattern. Whereas with the negative word list developed by Lofgren and McDonald, by extracting and analyzing the words from the 10K, they do see a correlation with negative returns and negative words. There's a clear linear relationship. Okay, so let's look at another question. Does the tone of forward-looking statements found in the management discussion and analysis section of the 10K, does the tone of these forward-looking statements predict future performance? So forward-looking statements would be those sentences that are discussing the future. And the hypothesis is that positive forward-looking statements sort of lead to positive performance in the future. The first task here is, how do you identify forward-looking statements? How do you identify all the sentences that talk about the future so that we can analyze the tone? So Feng Li, the researcher who conducted this study, said, well, there are a few special words that indicate that this sentence is probably talking about the future rather than the present or the past. And so he identified all the sentences that contain these words. And he found something like 13 million forward-looking statements in his data set. He wanted to see if the positive or negative tone of these statements were related to future earnings. And here are the results. So this is a little bit statistics for you. So on the left we have tone. So tone is positive. Tone is, say, greater than 1, that is positive. And across the top we have 4 variables. We have the earnings at T plus 1. That would be the earnings for the next quarter. So if you're looking at the tone of the current quarter and relating it to the earnings in the next quarter, and then T plus 2, which is the quarter after that, and all the way up to T plus 4. So the first result, 0.006, the 3 stars, shows a significant positive relationship between tone and earnings in the next quarter. Which means if the tone is positive, the earnings will be positive. And there's a significant statistical relationship. And that relationship decreases over time. So from T plus 2 to T plus 3 to T plus 4, where the significance actually goes away completely in T plus 4. So it's very interesting that, yeah, the positive language actually means something in the MD&A. So here's an interesting chart that Dr. Lee produced in his study, was that tone is mean reverting. So what he did is he took 5 companies and he divided them into quintiles. So the first quintile, the top line there, had the companies that used the most positive language. Okay, and the bottom line is the companies that started off, they used the most negative language. And he tracked these companies over like 48 quarters. And you can see that the tone is mean reverting. In other words, if companies were very negative at one point, or very positive, then they all sort of go to the mean. They revert to the mean. And that's kind of how profits go too. Profits are mean reverting. So companies just aren't always, bubbly or effervescent. That makes sense. So now you've seen some examples of textual analytics in the accounting domain. How can you do it yourself? And there are 3 main steps. First, you'll have to select the data, then prepare the data, and then analyze the data. So when selecting the data, what you need to do is first decide, what's the question that I want to answer? For example, what is management's attitude toward the future? Or what are the new risks the company is facing? Then think about the possible data sources to answer these questions. The public filings, interviews, board of director minutes, emails, web pages, news articles. There's so many different sources of text, and a lot of them are pretty easy to get. Once you've selected the data, then you need to extract it or gather it from whatever source, and then you typically just convert it into a plain text, like a notepad file, plain text file. Then you may need to remove some artifacts. So in these past studies, they never looked at the tables, so they had to remove all the tables. So they may want to remove what are called the stock words, the words that are common, like or the, or and, that, this. So removing the artifacts, processing the text. To be able to do these things, a little bit of programming knowledge becomes really handy. And you don't have to be a great programmer to process text, which makes it real nice and easy for a guy like me. Once the data is ready, you can analyze it. So what are you going to do? Well, you have to select the features of the text that you're interested in. So we were interested in past studies that we looked at, the tone, which would be basically the count of positive and negative words in a document. Those are features of the text. Maybe we're interested in the number of numbers that we find in the text, or the number of verbs that we find in the text. There are so many different features we can look for. They cannot be enumerated. Then you do your statistics, your machine learning, and you analyze the features to get the answer to the question that you asked initially. So let's take a look at another example, okay? So this is the risk factors example where we're going to do two different things. We're going to look at a company and detect the changes in the risks disclosed from one year to the next. And we're also going to look at two different companies and see if we can detect the differences in the risk factors. So back in around 2005 or 2006, the SEC mandated that companies disclose in Item 1A the risk factors that a company faces. So by doing this, investors would be aware of the important risks and that a company is facing, and they could decide whether to invest in a company or not. Well, this has become an important source of information for auditors who have to plan their audits according to a business's risks. And one helpful tool for these auditors may be to automatically analyze these risks and let them know in the planning stage of the audit whether there are any new risks or not, and also whether one company is disclosing risks that a competitor isn't. So let's take a look at the first question. Are there changes in risks from one year to the next for a company? So I'm going to look at Microsoft for no particular reason, except that they're a well-known company. And I'm looking at the risks from 2007 to 2008. I'm just looking at the risk titles. So the risk section, Item 1A, has lists of risk titles, a short description of the risk, and under each title there's a what I call the body of the risk. So it could be one or two paragraphs going into more detail about that risk. So here, in this example, I'm just looking at the risk title. So in 2007, here's an example risk title. Okay. Very short. Challenges to our business model may reduce our revenues and operating margins. We face intense competition. We may not be able to adequately protect our intellectual property rights. Okay, these are important risks. 2008, what do we see? Challenges to our business model may reduce our revenues and operating margins. We face intense competition. we may not be able to adequately protect our intellectual property rights. Okay? Alright, unless I'm mistaken, these are identical to the risks in 2007. So are all the titles identical? So to test this, I took all the risks from 2007 and 2008, and I matched them to each other just using a similarity algorithm, and detected how similar each risk was to the other. So I used what's called this token set ratio. Basically, what it does is it takes one of these risk titles and it breaks it into words, and then it sorts it alphabetically. It does that with all the risk titles, and then it compares these sorted lists of words. And it's kind of an easy way to see if the risk titles contain the same words or not. Okay, so here are the initial results. So along the left, I have all the titles from 2008. Across the top, all the risk titles from 2007. And then I have a heat map that shows how similar the titles are to each other. So in the very top left corner, I have Title 1 from Year 1 and Title 1 from Year 2, and they're identical. Okay, so the scores range from 0 to 100. And so you get 100, wherever it says 100, means that there is an identical match. Alright? So you can see the titles are virtually identical from one year to the next. There's one exception. Okay? What I have labeled as Title 20 in 2008 has no match in 2007. And that's fine. There's one more risk in 2008, so this is a new risk. We may experience outages and disruptions of our online services if we fail to maintain an adequate operations infrastructure. So now I want to look at the content of the risk factors. It's very possible that the titles remain the same, but the content or the amount of risk that's disclosed changes. Okay, so you can see here that I'm looking at the bodies of the risks instead of the titles, and still I get very high scores. And instead of the top left, instead of 100, it's 85. Okay, that's still pretty high match. And then there's a lot of hundreds and so on. So the content is virtually identical year over year, showing that the 10K received very little modification from the previous year. Alright, so Microsoft, guess you didn't see much change from 2007 to 2008, because you didn't disclose it. Now, what if we want to look at related companies and see if they disclose the same risks? Now, that's a really interesting question. So, in the technology industry, you'd think that similar companies would have similar risk profiles. But can I even compare the risks? Now, what's different between comparing a company with itself is the wording doesn't really change much. Because they've already, have the wording from one year, they're going to use the same wording the next year if they can. But if you have two companies, they're going to have their own way of saying the same thing. So it's going to be much harder to match in that case. Let's see what happens. So I compare Adobe and McAfee, two technology firms. First, I remove the stop words, which you remember are the words like the, of, and, if. Okay, common words. Then what I did is I gave weight to important terms. Okay, I used what's called term frequency inverse document frequency. The concept is really simple. What it means is if there's a word that appears in every document, it's not as important. Okay, but if it appears in only one document, it's very important. Also, if within one document, if a word appears a lot of times, it's more important for that document. But if it only appears once, then it's less important. What this does, what the effect of this is it gives a higher weight to important words. Okay, so search engines use this all the time. So if you search the word Rutgers in a search engine, you're probably going to get the web page most relevant to Rutgers would be the Rutgers homepage. That's because the word appears so many times on the Rutgers website. Okay, so it gets a higher score for this TF-IDF algorithm. So the result is I have a lot of zeros. Okay, I get a lot of titles that don't match at all with other titles. First of all, I removed the stop words, so it's not comparing common words. So we're only left with other words that, aren't as commonly used, and they're weighted based on importance. So if you look, let me see if I can turn on the laser pointer here. This is my highest score, okay, from 0 to 1. It's 0.87. I have a 0.70 here, 0.67, 0.58. I'm going to go 0.63. Okay? So first I found risks that were in one company's risk profile and not the others. Okay, so here's a risk that's in McAfee. We have experienced and may continue to experience material weaknesses and significant deficiencies in our internal control and financial reporting environment, which impacts the accuracy, completeness, and timeliness of our external statements. Okay, that's in McAfee, not Adobe. What about the other way around? Catastrophic events may disrupt our business. Okay, so these types of generic risks are actually not recommended by SEC. So it could obviously be part of any company's risk profile. These next two seem to communicate, something about Adobe's business. Maybe these are risks that McAfee doesn't face. All right. Give you a moment to read those. Okay, so let's see how well the risks match up between Adobe and McAfee. So I'm going to start with the highest ranked risk. It was like 0.87. So here's the risk in Adobe. Adverse changes in general economic or political conditions in any of the major countries in which we do business could adversely affect our operating results. And here's McAfee's way of saying basically the same thing. Conditions and changes in the national and global economic and political environments may adversely affect our business and financial results. So you can see the keywords match pretty well here. Political, adversely, results, business, conditions, economic, right? There are a lot of matching keywords that have probably a high weight from the TF-IDF algorithm. Okay, and in this example, there are two Adobe risks that match well with one McAfee risk. Okay, so the first one says we may incur substantial costs enforcing or acquiring intellectual property rights defending against third-party claims as a result of litigation or other proceedings. Okay, and the next one's kind of similar, and here's the McAfee risk. We face numerous risks relating to the enforceability of our intellectual property rights and our use of third-party intellectual property, many of which could result in the loss of intellectual property rights and so on. All right? So I think the algorithm did a great job here matching the Adobe and McAfee risks. All right, Adobe risk. We may not realize the anticipated benefits of past or future acquisitions, and integration of these acquisitions may disrupt our business and management. And McAfee risk is much shorter. We face risks associated with past and future acquisitions. So get those words, past, future acquisitions. And that was enough for the algorithm to detect the similarity between these two paragraphs. Okay, 0.49. Worked really well. Okay, here are some risks about distributors, risks about the delays in development and shipment of new products. Okay, so even when the numbers get really low, this means that there were a few keyword matches, but since they're related companies, we get really high results in identifying similar risks. So what's the conclusion? What are the conclusions we can draw? Okay, first of all, text analytics has many, many, many applications. I just showed you a few short ones here. Hopefully to whet your appetite, hopefully to get the wheels turning in your heads, thinking about what data sources you have access to, what types of questions you can answer. It is not that big of a leap to go from knowing nothing to doing some analysis where that would be considered text analytics. So researchers, are flocking to this area because it's such tremendous, diverse, expansive data source that we can answer questions that we haven't been able to answer before, or add on to areas of interest that we've been exploring in the past. So text relates to everything. There's so much to analyze and evaluate, and that's true in the business world as well. So for accountants, it's going to be up to tech-savvy students or interested students like you to implement real-world solutions that have material impacts on your organization's bottom line. Thank you very much.